question from a student here about question 29 from lesson 222 on curved mirror reflection. The question states, a convex mirror is used to produce an image that is 2/3 the size of an object and located 12 centimeters behind the mirror. What is the focal length of the mirror? Our first task is to identify information in the question and list it in a table. Let's go. Notice how the image is 2/3 the size of the object and located 12 centimeters behind the mirror. What is the focal length of the mirror? We first need to solve for the distance of the object. We won't be able to solve for the focal length using the mirror equation until we have these two values. Let's solve. Notice how the distance of the image is negative 12 centimeters. The negative sign stands for behind the mirror. Here's our magnification equation, where the magnification factor is equal to the negative ratio of di over do. The negative sign preserves the convention. A positive magnification means our image is upright. A negative magnification means our image is upside down. Rearrange the equation to solve for do. That's the unknown we're solving for. Let's solve. When we plug in the value for the distance of our image, negative 12 centimeters, and the magnification factor, which is 2/3, and solve for do, we get a do of positive 18 centimeters. Let's solve for the focal length of that mirror. Now we've got the di value, which was negative 12 centimeters, and we just solved for the do, 18 centimeters. Before we can solve for the focal length, we need to rearrange this equation to solve for f, which is a little bit harder said than done. Before we can solve for f, we need to be able to flip this fraction, 1 over f to f equals. But in order to do that, the right-hand side of our equation, 1 over di plus 1 over do, we have to get it over a common denominator. How do we do that? If we multiply 1 over di by do over do, which essentially accounts for 1, any number divided by itself is 1, we don't change the value of 1 over di, we just change how it's expressed. Let's do the same for do. Now that we have each of those terms over a common denominator, we can combine them. Into 1 over f equals do plus di over di times do. Now we can invert these fractions by raising both sides of our equation to the power negative 1. In so doing, we solve for f. Flip both those fractions. Now we have di, distance of our image, negative 12 centimeters, and do, the distance of our object, positive 18 centimeters. Let's plug in our known values and solve for f and complete this question. Remember, earlier on we preserved that negative sign by taking care of our sign convention. It becomes especially critical here, as if we don't have a negative 12 centimeters for the distance of our image, we end up with a very, very different final answer. We simplify the numerator to 216 centimeters squared and the denominator to 6 centimeters. And we get our final answer, negative 36 centimeters. This is the focal length of the convex mirror that was used to produce the image 2/3 the size of the object as described in our question. Right on. Good work. All right. Thanks for watching, everybody. Good luck. Take care. Bye for now.